From 5G networks to aerospace systems, from artificial intelligence to quantum technologies, from behind the scenes of innovations to real-world applications. Welcome to Innovations Unplugged, the Rohde Schwarz technology podcast. Yeah, hello, I'm Inga Müller-Siedentop.
And I'm Markus Haller. Welcome.
We're happy to host this show about bringing mobile connectivity from the ground up into space, connecting satellites with terrestrial network infrastructure and even your own mobile devices. We explore 5G NTN, that's 5G, Non Terrestrial Networks, one of the most exciting topics in mobile communications, mobile connectivity these days.
And the big promise behind non-terrestrial networks is better coverage for your and my mobile connection, for my mobile phone. And we are more than happy to have a colleague, a tech expert, Tim Seiler, today with us. Tim, welcome to the show.
Hi, thanks for having me.
Maybe we can start with a kind of personal story here. When we talk about better connections, I would add sometimes we talk about connections at all. I'm from the very north of Germany. It's called Ostfriesland.
I know where this is heading.
And when I visit my parents, I still have sometimes problems with the mobile network coverage up there. Maybe we can figure out why it is, but there are other use cases when coverage is not there. We talk about catastrophes, we talk about earthquake regions when mobile infrastructure is critical but not a given. And sometimes, regarding these days, we also talk about geopolitics when there are intentions not to have mobile connectivity for some regions.
Tim, do you have some facts and figures for us to grasp the scale of dead spots today?
You have to consider how many areas are basically completely uncovered by any cellular coverage, like, for example, the sea. Yeah? Mm-hmm. But also when we look into other use cases like search and rescue or emergency cases or critical infrastructure, it's getting a really serious problem how to solve these issues and how to get the coverage where you need it.
Maybe one step back, we figured out we do have dead spots, we do have coverage issues. Why is extending the classic terrestrial infrastructure not an option?
The one thing is how the environment looks like. When we think about mountains, putting cables up there with the whole infrastructure is a lot of work. So it's very expensive. The other thing is also when you look into scaling, so let's say you have now an area where you say, okay, here I want to install a new base station because I expect more users. But what about in another area where you have not considered that at that point, more users are coming up? You need to rethink your infrastructure again and again. So it's like basically a run against the time, how many people will come to a specific area or the demand will get higher and higher. Mm-hmm. And the advantage here with the satellite is there, the coverage is already there, and you can scale it much faster. You can scale it on demand, on the fly, depending what bandwidth maybe you need or how many users you expect. Or you can also just temporarily activate it, which is, for example, the case in areas where you have earthquakes or something like that, where you need very fast, a big coverage of satellite communication for the people or just temporarily. But if you don't need it, you can just disable it again because the cellular network is back.
Fill us a bit more in. What's the difference when we talk about existing satellite comms? The sailor who has like a satellite phone on his boat, cruising through the seas. And we do have terrestrial comms.
Yeah, so the difference is basically in how it is technically implemented. That's the one thing. And how is it approachable for the consumer market, for the mass market? The operator, which are nowadays offering basically the satellite coverage, they are doing a very good job. They are doing that for a long time, and there is no other option. There are very few operators, for example, where you can go to the South and North Pole. This is very difficult to cover, but you cannot bring that to the mass market, to the consumer market. Why? Because you need dedicated devices. And I don't know whether you have seen how a satellite phone looks like. I tell you, it's very bulky. It's a little bit bigger than our phones.
It's like the mobile phones we're coming from, right?
Kind of, yes.
The suitcase of mobile phone, kind of.
Kind of, yeah. And in this case, the idea is, because you ask what is the difference, that basically the satellite communication is integrated from a technical aspect to the normal phone communication. So the phone can talk basically cellular, but it can also talk satellite. But it's all in one device. And this is the magic behind it, that these technologies are combined and not running as a separate stream anymore.
Tim, so we learned there's a need for it, and it's a good idea to go to space with your connectivity. And the obvious question is, why don't we have this already? What are the challenges you have to overcome to make it real?
Well, the normal cellular communication is working. You're connected to a base station, which is maybe just a few kilometers away, right? It's located on a building or somewhere, and you don't have a lot of things you need to consider at that point. But the big challenge is we go up to the sky. So we have, for example, very long delays. We are talking about satellites. They can be 36,000 kilometers away from us. This is a completely different scale than when you consider 5 or 10 kilometers.
Okay, I'm starting to see this is a real difference. Why is that a big problem?
Well, when we have a phone call or a video call, for example, and there is already a slight delay in the communication, you start interrupting each other all the time. Because before I'm done with my sentence, for example, right? You maybe also start talking, and then we are in kind of a deadlock. So the first problem is really this real-time applications where timing is very crucial in the communication. This is where the delay kicks in very hard, and you need to try to find solutions that you can kind of overcome or work at least against it to some point of extent.
So, okay, the thing is, we got a 5G communication, and this works in very close distance, and now we got much longer latency times, and you have to make the whole mobile communications infrastructure and protocols work with that. So it sounds like a huge task to refit all of this.
Indeed, it is. So the idea behind that is that the phone and the base station, when we talk about cellular, they're exchanging information all the time, that the signal can be adjusted. And the good thing is, with the NTN extension of 5G, these messages were basically extended, for example, that the phone knows how far is the satellite, in which direction is the satellite going. And this information can help to pre-calculate the communication, basically, to make it working as good as possible.
And that was just one challenge. So what else do you have to think about?
I think one of the biggest challenges, in addition to the delay, is the moving, right? So a base station normally doesn't move. So a base station is installed somewhere, and you as a user maybe is moving, right? With a car or in a train or by walk. But in satellite communication, when we talk about the satellites which are around 500 to just a few thousand kilometers away, they are moving very fast. So they are coming and going all the time. And here, the big challenge is to keep the signal still continuously connected, basically, that the end user does not even see that connecting between thousands of satellites back and forth over the time is happening.
But the signal is hopping, kind of.
The signal is hopping, exactly. And the phone and the network is so intelligent that they try to make this handover between the current satellite and the next satellite very smooth. So you don't really see it. You don't feel it. It's so fast that as a user, you are just online, right? And this is, from a technical point of view, this is a big challenge. So in 5G NTN, LEO low Earth orbit, closer to the Earth's surface than this geo orbits. So the runtime of the signal is much lower. So we are talking about 20 milliseconds. So here, applications like a video call or an audio call feels much more natural and better. But since we are very close to the Earth, the satellites are moving, and that causes the drawback compared to the geo, which are fixed. We have to do a handover all the time.
You just dropped the 20 milliseconds? Is it from Earth to satellite, or is it like the whole loop from device to device? What are you counting here?
In this case, you can say it basically as a round trip time, but this is really the absolutely calculated under perfect conditions values, which are normally communicated. Normally, the variance is very high here because it depends on weather conditions. For example, if we have very heavy rainfall, snowfall, clouds, this has a huge impact on the signal. Why? Because the distance is so far. Normally in cellular communication, when you have rain or snow, you don't care. The phone doesn't care, right? Because the distance is very short. But here, distance is so far that the signal is getting so attenuated, you will feel that at some point. Yeah. So we can say that the factor basically of from a LEO to a GEO satellite, we are talking about like 10 to 15 times from the runtime, right? From the signal delay, which also depends on the applications, what you can do. Via a GEO satellite running a video call will not be possible because it just takes too long. We are talking about seconds of delay in a real test environment.
How does Rohde and Schwarz fit in here? We are not producing mobile phones. We are not producing satellites and not sending them up into space. What are we doing, and why is that so important?
You have to know that there are so many parties involved. Yeah, we have the chipset companies. We have the phone manufacturers who might integrate their own chip or another chip. Yeah, we have the satellite network operator. We have the mobile phone network operator. So there are a lot of parties involved that this is working. And all these parties, they require to validate and test their part or maybe other parts that they can say, my equipment is properly working and talking as my phone will expect in the future. The demand to really verify each and individual step of this whole chain, this is what is required basically from the companies who are offering the end device, the consumer device, parts of that, or the infrastructure. And the equipment we as Rohde and Schwarz offering is basically that we can emulate different parts of this chain.
And just to make it clear, when we talk about emulating, we kind of imitate real signals.
Yes, it's a real signal, yes. Yeah.
We know the specifications of signals that are around, and we are able to reproduce them and to check if the devices, for example, as you mentioned, as a mobile phone, is working in that environment as it is supposed to work, right?
Correct. And why is that so important? Because for the phone is connecting to our device, but the phone doesn't know we are basically just imitating what the phone is seeing. And that makes it so interesting because we are under control of the signal which the phone can receive. And then we can do measurements.
Can you give us a brief concept of what are we talking about when we talk about the signal?
So basically the one of the parameters, one of the things the phone is evaluating to communicate is how strong is the signal. You can imagine like how loud are we talking? Okay. So the further you are away, the louder I have to be.
Yeah,
right?
for sure.
But even if I'm talking very loud, there could be a construction going on next to me. Yeah. So my loud talking will not help anymore. So I need to find other ways to, for example, eliminate this background noise that we can still have a clear communication. And all these kind of things to make the communication, the voice or the tone in our case, which is transmitted from me to you, needs to be as clear as possible. Why? Because the clearer it is, the more information we can share. Mm-hmm. And if there is always somebody who is interrupting us, some information will get lost. Mm-hmm. And I have to tell you again. So I have to retransmit the information again and again until you get the information. There are a lot of things on which the signal quality, right, depends on. And depends on this quality, you can make different applications, right? So a text message, if it takes longer because it has to resend and resend, doesn't matter. Mm-hmm. But the moment we want to have a voice call, we will feel that, we will hear it very, very heavily, like my voice is getting more robotic, for example, or there is a cutoff. So that's why this is the key of any communication.
And you mentioned that applies for mobile network operator who's sending the signal in a 5G scenario up into the space, but for satellite providers also, right? What do they do or want to do with the signal that we can help?
Yeah, basically what they can do, they don't create the signal itself. So a satellite operator is just taking the signal which it is getting from the ground and forwarding it to the phone in this case, or the other direction.
It's a bit like a repeater.
Exactly,
I know, from
you can see
home,
it as
right?
a repeater, correct. And in this case, what can be tested, or what we can do in this whole test chain is, we can, for example, make the signal to the satellite worse. We could degrade the signal and see at which point is the link between the satellite and the phone dropping, for example.
Okay,
and these thresholds are very important to play around for operators to see the robustness, to test the robustness, for example, of their network in this case.
I'm starting to see the big benefit for, let's say, a smartphone company. They basically have a whole mobile communications network in their development lab, and they can control this network, which in reality they would never be able to.
Absolutely correct.
So,
yes.
And now I'm starting to see what big of a task this is, knowing all how the signals have to be created and how they have to respond to and interact with the phone. Fill us in. How do we tackle this?
So basically, the devices, which in this case is used for emulating NTN network, it can do everything in one box. So it has all the technology integrated that it can do, for example, a LEO orbit with very fast moving satellites. But we can also, for example, deploy a GEO satellite network where the delay is the issue.
I'm hearing some of our audience who may never have been in touch with us and may not be familiar with this pretty little term of a box that covers everything. Maybe you can give us a bit of a picture here. Like, what does Rohde Schwarz contribute here specifically?
Our boxes, so-called, they have different applications, right? So in this case, what is normally used is called a network emulator. So it emulates a network. And in this case, we're talking about a satellite network or a mobile network or both, right? It can also do both. And another part, which is very interesting, is basically that we are also able to do, I would say, like real life testing, for example, with satellite operators. So what we can do, we can connect our network emulator on the gateway of a satellite operator in the real field and do testing. And why is that necessary? Well, a satellite network operator, they are the experts in satellite, but there are no experts in mobile communication normally. So they don't have the equipment, the infrastructure, maybe also not the knowledge. And we are bringing in our network emulator and we can say, hey, you have your satellite network, your live, real satellite network. We are just acting as the rest of it. And then they could verify whether their satellite network is basically supporting 5G NTN.
They need to make sure that this kind of constellation works, right? And they can do try and error, which wouldn't do that great. And I guess it's also not allowed to do try and error here. Thinking about standardization bodies, authorities.
Yeah, I think if everyone could just create a radio signal, things would go very wild. And luckily, this is not allowed. There are groups, and for us, for mobile network communication, cellular communication, but also now the 5G NTN, the so-called 3GPP, is a group where worldwide different, you can say, members are part of it, from phone manufacturers, chipset manufacturers, satellite network operators, mobile network operators. And these groups are defining how this communication works. And this idea of that is that basically the whole world who is specifying and defining these standards of communication, it makes the things also interoperable.
Rohde Schwarz, as test and measurement in the field, can shape this actively.
Of course, we are part of this shaping. We have people sitting in these groups. And this is a very important part of our work because the technology is developing very fast. And you need to be fast to be first. And how can you be first if you have the information first?
Coming together, talking about specifications could sound a bit like dry or like, okay, we need to do this, but actually it's driving the future technologies, right?
It's very important. Without that, we would not be here where we are now, right? And when you consider how complex this communication already is nowadays without satellite, a lot of communication flow is happening between a phone and a base station or a phone and a phone. And with satellite, this level of complexity is so extreme in addition that now it's even more important that you're really very close to what is happening outside. And we are talking about discussions of features which will come maybe in 5, 10, 15 years in the future.
I remember when we were talking, shall we do a podcast episode on 5G NTN? You said, yes, let's do this. This is such a hot topic. What excites you personally so much about it?
I love the technology behind it. And here at Rohde Schwarz, we are at this forefront of these technologies. So we always need to be like the first place, right? This is the key. And having this pace to understand and to learn these technologies is for me very fascinating in general, no matter what kind of technology we're talking about. So this is the first thing. And the second thing I would say are the use cases, because we can cover use cases, we can look into use cases, and we can extend use cases which we have never thought about. Yeah, we talked about coverage in areas where there is no possibility to install an infrastructure. How there is no way to do that. Yeah, so this is a new case where there is a solution in the future. The interesting part will be who will do what and when. And that makes it interesting and fascinating to stay with this technology, to look on the market, to talk to customer, to the industry, and to just to understand where this whole thing is going. And the moment we know roughly where it's going, that we are there with the solution and the customer can rely on us.
So exciting times
Absolutely.
We are living in.
Tim, thank you very much for your time. It was a pleasure talking to you. We
Same.
learned so much. I'm looking forward to what is coming, because that really is a thing we will have to deal with personally with our devices in the future, I would say.
Yes, Tim, thanks a lot. I learned a lot and I'm excited in seeing this becoming a reality. And with that said, we say thank you to all of our listeners. Make sure to check out the show notes for additional information on 5G NTN. And if you would like to meet Tim at the Mobile World Congress, you can do. Feel free.
Yeah, thanks and see you in Barcelona. Bye.